Got off on the tangent of doing the calculator yesterday on this one. And we learned a few things, but I did want to finish it off just so you have some closure in case you were wondering. You can do this without a calculator. Here's why. We were right. This is the only critical point. Pi over 4 was the only place where the function was 0. So we were good on that. But it's increasing starting at its lower. Remember our interval was starting at negative pi over 2, so the lower bound. It was increasing from there until our critical point, the whole way. And we knew that because the cosine is greater than the sine. So all of these values would be positive until we hit pi over 4, and then it switches. So do you guys remember that problem enough to get something out of what I just said? Yeah. Okay. Okay, real quick, I have this here. How would you describe the slope on a concave up function?
Always.
Okay, so the slope is increasing. And just to remind you, like it's very negative there, less negative there, and then a little bit positive and more positive. So it's always increasing, the slope is, and then the vice versa on the other one. Okay? Okay, so thinking of derivatives, we now know that critical points occur where? Yeah, go ahead, Pedro.
What? Oh, I was thinking about something else. Yeah, okay. But it's like
you guys just showed me 4s and 5s on this.
The derivative is 0 and it's non-existent.
Okay, so when the derivative is 0 or non-existent, right? Well, how are we going to decide between a minimum and a maximum if all we know is the derivative is 0? Does that make sense? Because both of those derivatives equal 0. One's a minimum, one's a maximum. So what do you think? Where do you think this is going?
You gotta check both sides.
Yeah, like probably more tables, right? What did you say? Actually, we won't be doing limits, thank goodness. Raise your hand if you like limits.
Put that down.
Oh, good job. I don't think I would raise my hand. I think it's a cool concept, though. All right, so we're calling this the first derivative test. And it should probably be hyphenated in case you're a linguist. This isn't a first test, but a first derivative test, meaning we'll see another test later where we take the second derivative, okay?
So it's not the first derivative test, but it's the first derivative test.
Exactly. Perfectly stated.
English.
All right, so the first derivative test is when we use the first derivative to test whether or not a function has a maximum or a minimum. What did we just get done using the first derivative for? Nope. I'm saying just, like last night, yesterday.
Wait, I don't know. I wasn't listening.
Okay, well, here's why. I'm asking you this for a reason. Like he said, we have done first derivative for velocity. That was specifically in context. Yesterday, we found critical points with velocity. Well, the last 2 days. Yesterday, we also found something else using the first derivative.
The signs.
And I'm asking you because this is going to get jumbled up if it hasn't already. Okay? Because think of critical points. Yesterday, I'll just tell you, we were doing intervals of increase and decrease, right? So that's the second thing. Now we're talking about minimums and maximums. And we're going to add concavity. And these are all kind of centered around derivatives. Do you see what I mean by the potential for jumbling it up? So what did we do yesterday with derivatives?
Increasing, decreasing.
Yeah, intervals of increasing and decreasing. And critical points. So this is a different question, right? Maybe highlight that we're talking about maximum or minimum. How do we test using a derivative if it's maximum or minimum? Well, let's see if this helps. So something you know, x squared minus 4x minus 2. There's the graph of it. So we know we'll have a minimum, but it says examine the graph of this parabola and describe the behavior of f prime around the minimum. What is f prime again? You guys probably didn't hear this, but Trevor told me that we should buy shirts that say a derivative is the slope of the tangent. Something like that.
We should order them for all of us and then we pay
That's
you.
what he said. Like, you guys think I'm rich.
No, we pay you.
I'm not saying I'm not. No, I'm just kidding.
That $500 gift card might help.
Yeah. Okay, so it's the slope of the tangent, and if you don't have to do this, I'll do it so I can erase, but if we draw in a few, what's happening, and I kind of asked you this a second ago, but what's happening to the slope of that tangent as we swing around this minimum? What is happening to the slope?
It is increased.
Okay.
It's approaching zero.
I'm going to leave those on mine, I guess. So it says describe the behavior of f of x around the minimum. Now, I want you to think about the tables that we made with intervals of increase and decrease. Did we ever find a specific value?
Except for the
What were we mostly interested in? Sine, right? Okay. So around the minimum, what happens to the sine of f? Or I shouldn't have said f. I should have said f prime. Sine of f prime changes from what? Look at my awesome picture. Negative to positive, right? Okay. That's what's going to be true if it's a maximum.
It switches from positive to
Okay.
negative.
So if you look at this, am I going to block you if I'm right here? Okay. If we look down at this box, assume C and D are critical points or critical numbers of a function. There is a minimum value at x equals C because y? Yep. The sine of f prime of x changes from what?
Negative 2 positive.
Now we have to be specific on this. So far we've justified things by saying just that they have different sign. Like something is increasing in speed if the velocity and acceleration have a different sign. Excuse me, if they have the same sign. It's decreasing in speed if it has different sign. That was okay back then to just say different. But now we have to specifically state that it's negative to positive. So be specific. All right, and then how about the second one? Well, by the way, if you read the box title, I should have done that for you. This is what we're going to write when we justify how we know there's a minimum or a maximum. We're going to say because what we're writing here. Because the sine of f prime of x changes from positive to negative. Okay. How do we do that? Like, how do we know? Here's some ugly function. X squared minus 4 to the 2/3. And I guess let's, before we do that, I want to make this note out to the side. It doesn't really make it clear. So the first derivative test is for local max min. Always cuts it off. So this is, and it says in here, it says relative. I like local. If you have a preference otherwise, go ahead and write what you like. Why not absolute?
Because it needs something different.
We'll have we're going to do a different thing for that. Yeah. No. Well, it's called a candidate's test. Candidate. Anyway. I feel like some of you aren't with me. Are we good? Are we going too slow?
Oh no.
Okay. Are you good? Is this too slow? I can speed up.
Mr. Hank said, look what you've done.
What have I done? Made you point at your cheek. I can point at my cheek too. There's tissues over there, by the way.
Oh, shit. Yeah, I need a tissue.
All right, first derivative of this guy. I would like you to try that before I tell you, just for some review.
Oh, come on, that's light. Watch this.
No, it is changing. It is changing.
All right, here's that. The first line is just the application of the power rule and the chain rule. And then the second line is kind of back to a function looking thing. And you don't, for this, it's up to you. Which one are you going to be able to find the sign of it better for, or solve better, right? So what do we need to do next? Can we start making our table yet?
No.
Do we know where to check?
No.
No? So what's the next step?
Find the points.
Critical points, right? Please narrate or annotate your work. Here's what I mean. Like here, it's clear I was finding just a general f prime of x up there. I probably should have written it smaller. Now I'm saying this is where I'm doing critical point work. Annotate your work. It makes it easier for you to follow when you do this. How do we find the critical points for this guy?
You can do the top for
Is that in here?
zeros. Sorry.
Okay, note I'm saying f prime of x equals 0. That's one of our versions. Where does that happen for this one? At 0, but do make sure that it doesn't make the denominator 0, because that would not work. And in this case, it's fine. So that's just setting 4x equal to 0, which I'm okay, so we have a critical point at 0. What else do we need to check? Yeah, so this is where it doesn't exist. And yeah, for that, I'm sorry. Okay. Is it ever going to be negative? I mean, inside that denominator. It's cube root. So do we care?
No.
No. Okay. All right, now we can set up our table and check. What goes in our table? What goes in the bottom?
After the left side, side of
Okay.
Yay, Trevor, good job.
Let's go. No more tears. Look, my cheek is dry now.
Give it a second.
Oh my god.
Oh no, I ran out of room.
Yeah. That's an issue on these, isn't it?
Yeah, it's fine.
Remember to leave. Yeah. Oh, I put 2 negative 2s. Thank you. What? Why is negative 2 not part of the function? Oh, yeah. This is a cube root, right? So it's like this shape. All right, what's the sign of these? Well, we know it doesn't exist. Oh, you guys think we're going? No, I'm just kidding.